Hi, little turkeys. All right, a few of you have expressed some frustration this week with this week's practice problems, so I just wanted to quickly talk you through a few of these here on my answer key. So for the first one, draw a tree diagram for the total number of outcomes for randomly drawing one of these blocks, right? So it says in the directions that there are small blocks, there are large blocks. So right off the bat, you've got those options. Then they come in 3 different colors, red, yellow, and blue. So for each type of block, small or red, you can have a yellow, small or large, you can have a yellow, red, or a blue, or a yellow, red, or a blue. And then with each of those, they come in a thin, thick, right? So what that shows us, and I want you guys to see where I'm looking, but I also don't want it to be too busy. If you look, how can I do this? All of these right here, those are our final options, right? It could be small, yellow, and thick, or small, red, and thin, or, there are lots of different options, but ultimately that final end of the branches, those are all of your possibilities. So in this case, there are 1, 2, 3, 4, 5, 6, 12 possibilities, okay? Now here for numbers 2, 3, 4, 5, and 6, I went ahead and color-coded, or not 2 through 6, 2 through 4, 2 through 5. God, I'm out of control, you guys. 2 through 5. I color-coded them over here, and I hope that that's helpful. So how many outcomes are possible? I'm looking at number 2 right now. I did a little yellow dot by all of the possible outcomes, right? So there are 12 possible outcomes. For number 3, how many outcomes will be red? Well, I color-coded that one in green, which doesn't make sense. And you could have small red, so there are 2 options. And then you could have large red, there are 2 options. So there are 4 total options there. How many options will be blue and thin? You can see we've got 2 options, right? Blue and thin, blue and thin. So there are 2, and I've got those blue dots. And then how many outcomes will be large? That's half of them, right? So all of these guys down here are large. So I hope that that is helpful. And for a lot of the questions you guys are going to get, drawing some sort of model, whether it is a tree or the area model, is really going to be helpful for you, at least when you answer maybe one of the first questions. And then it kind of helps give you a visual of, what it is that you're working with. Number 6, suppose a medium size is also available. How many outcomes are possible? So if we've got thick, thin, and a medium, we're really going to take each color and just multiply it by 3 instead of the 2 options, right? So since there were 6 color options, if there are now 3 thicknesses, we would do 6 times 3, which is 18. Okay. Moving down, a box contains 10 balls numbered 1 through 10. Marisha draws a ball, she records its number, and then returns it back to the bag. Then Penny draws a ball. Find each probability. So when you see something like this, that means what is the probability of... Oh, my pen's not working. What's going on? Oh, no. What is the probability of... sorry, I'm plugging this in. Of drawing a 9 and then a 3. Well, if you look down below here where I wrote number 7, and I've got only a part of a tree, because drawing this one would be pretty intense. For your first draw, you could pick 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10, right? These right here, there we go. Cool, it is working now. That's your first draw. Then you put them back. And I only did 1 kind of coming off of the 5, but you imagine that there are these branches coming off of each one of these, right? 10 branches coming off of each. Because for that second draw, it could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you first drew a 1, you could then draw a 1 through 10 the second time. So if there are 10 options the first time, and then 10 options the second draw, 10 times 10 is 100. So our denominator here is going to be 100, right? And if you to draw a 9 and then a 3, there's only one way that could happen. So it's going to be 1 out of 100. The next one's a little bit interesting. What is the probability of drawing an even and then an odd? Well, again, so our first draw right here, sorry, I feel like maybe the highlighter is easier to, our first draw, the evens here, right, are 2, 4, 6, 8, 10. So there are 5 even options. And then For our second draw, to draw an odd one, there are 1, 3, 5, 7, and 9. So that is 5 coming off of each of the evens, right? So 5 even options and then 5 odd options. 5 times 5 is 25. So there are 25 different ways that you could do that out of the 100 total ways. And 25 1/100ths is equivalent to 1/4. The next one here, what is the probability of pulling an odd and then a 2? Well, an odd, we talked about, right? There are 5 ways to pull an odd. And then to pull a 2, there's only one way off of each of those, right? So 5 times 1 equals 5 out of 100, which can be simplified to 1/20th. Okay, I hope that that is helpful. I'm going to scroll along here to our next practice page. Irene randomly tosses a cube onto the grid below. Express the probability of each outcome as a percent. So far I've just done them as fractions. Just a reminder, we divide our numerator by our denominator to get the decimal that then tells us our percent. So we'll do that here in a second. What is the probability of the cube landing on a striped rectangle? Well, I noticed here that there are 1, 2, 3, 4, 5 by 4. So there are 20 total rectangles. In a striped one, we've got 1, 2, 3, 4, 5, 6, 7. So there are 7 possibilities of striped out of 20 total. So 7 divided by 20 is 0.35, which is 35%. Right, let's just do one more of these. I'll pick it at random. What is the probability of a cube landing on a dotted rectangle? Well, let's go ahead and look. 1, 2, 3 out of 20. So we've got 3 divided by 20 is 0.15, which is 15%. You guys are amazing. Let me know if you have any questions